Hello everyone. In this video, I will be conducting a simulation using ICSim. ICSim stands for Instrument Cluster Simulator. It's a tool designed to simulate a vehicle's instrument cluster, often used for testing and research purposes, especially in the realm of automotive security. Now before we jump into the demonstration, I'd like to mention that I've already taken care of downloading all the necessary dependencies. This will save us some time and allow us to focus on the core functionality of ICSim. I'll be running ICSim on my Linux virtual machine, and I'll walk you through the steps to get it up and running. So I have these two terminals opened, and all I did was cd into the file. Then I typed in /ICSim vcan0, which opens up the interface. Afterwards, I opened up a different terminal, cd'd into the file, and typed /controls vcan0, which opens up these two panels. So from here, I just want to demonstrate that when I click on the up arrow, it will show the speedometer going up, and I believe it goes up to a max of 100 miles per hour. Then I can also hold my right shift and click A, and it'll open the door, or unlock the door, I mean. And then if I hold left shift and A, it will relock the door. So with the speedometer open, it will provide us real-time feedback mechanism, mirroring how an actual vehicle's instrument cluster would respond to various input and commands. Now that this is set up, we can test in a safe environment while we understand complex interactions. Alright, let's begin understanding some CAN traffic now. CAN stands for Controller Area Network, and it is the foundational technology for vehicle communication. It is designed to allow microcontrollers and devices to communicate within a vehicle without a central computer. There are three core utilities we will be using. The first one is candump. So I've already typed in the command candump-c vcan0. So as the name suggests, candump is used to dump all the traffic that is seen on a CAN network. It captures and displays all CAN frames that pass through the specific CAN interface. So let me cancel this now. To go over what the data means, the first column is which device it is listening to, so vcan0. The second column is the CAN ID, which corresponds to some kind of utility, such as the brakes or the speedometer. The third column is the length, and the fourth column is the payload in hexadecimal. So the next utility I will be discussing will be cansniffer. So the command I typed in is cansniffer-c vcan0. So cansniffer is more selective. It's designed to display only the CAN frames that have changing data. This makes it useful for identifying and focusing on active or interesting parts of the CAN traffic, especially in a busy network where constant data update can be overwhelming. So let me cancel this now. And column 1 is associated with timing. Column 2 is the CAN ID, which corresponds with some kind of utility, such as brakes or speedometer. The next column, column 3, is the payload in hexadecimal. And the last column is ASCII. So wrapping things up, the last utility is cansend. Cansend is used for sending data onto the CAN bus. So let's consider a hypothetical scenario where an attacker wants to manipulate the speedometer reading of a vehicle, displaying a speed of 80 miles per hour, even if the car is stationary, which confuses the driver. First, the attacker will need to identify the CAN ID associated with the speedometer, which in our case would be 244. So afterwards, the attacker will craft a malicious message by sending the payload of 00002F00, causing the speedometer to display 80 miles per hour. So let me X out of the control panel and then send this payload, which then shows a reading of 80 miles per hour. So such an attack can cause the driver to be confused, leading to unsafe driving conditions. This demonstrates how an attack with knowledge of the CAN protocol and the specific vehicle's CAN message structure can manipulate vehicle behavior. By sending specific messages, we can observe how different systems or devices on the CAN network respond, allowing us to understand their behavior better and test potential vulnerabilities. Tools like cansend, candump, and cansniffer will allow us to analyze, understand, and interact with the CAN network.